Okay, so I know that we are ready now for phase 2 of Dystopian Water Wheel project, which is jumping into the CAD. So I have a couple of examples I'm going to show you, and then I'm going to kind of show you how to get started. But here's one example. You can see it has a water wheel. It's got some gears and whatnot. I'll kind of go into this. You can see that it's got like shafts for all the gears, and they go through this wall right here. And you can see how, for example, this just looks like these gears just are all idler gears, and it just gets you over there. So it doesn't look like this person did the nesting of the gears properly, because there should be a compound gear system. But this does give you a general idea of how it should work. I'm going to show you on the next example a better example of how the compound gears work. But this shows you a general idea of how you have like shafts going through a ceiling, through a wall. It shows you that it's all connected. So when I make this move, see how the fan's moving? But you can see that there's some things wrong with this. So like, for example, when this moves, yeah, you can see how all the gears are moving. So the wheel is causing all this to move. And so here, if I hide this wheel, let's see, which one is it? If we hide the water wheel, you can see that as I rotate this, so you can see that this gear is mounted on this shaft. Everything that's on one shaft should rotate together. And then you can see that that gear, if I hide this, so there is a little bit of compound gears going on. So here, you can see that this gear mates up with that one. And let's look at the dimensions of this. So that one is 27 inches, and this one is 9 inches. Now, this person did not do their room to scale. It would be better. It's better to have your room to scale, because you can see how big this 27-inch gear. The 27-inch gear should not be that big in comparison to your room. It should be more realistic, because the 32-inch diameter gear is almost 3 feet. So you need a life-size room for that. Okay, but you can see that runs into that, and then because this gear is on the same shaft as the other one, if I hide that again, when this rotates, let me see. Sometimes I don't grab the right handle. Yeah, when that rotates, it's causing this little gear up here to rotate, right? So when that gear rotates, then this gear, because it's on the same shaft, will rotate. And so then when this rotates, you can see it's causing this gear up here to rotate, because it's connected to that. So this is a right angle where this gear is connecting with that gear, okay? And so as that one rotates, this little gear rotates, and again, you have a compound gear. So when this gear rotates, everything on this shaft, which includes this gear, rotates. So I know it's a little bit confusing, but you'll get it. Just go slow. The other comment about this is this person did not rename any of their mates. So if they had made a mistake or anything went wrong with it, it's going to be really hard for them to fix it. So in general, this is a good idea. It has a lot of the bones that I'm looking for, but it does have some things that could have been better. It could have had a life-size room, for one. And it looks like maybe they did do the compound gears. I'd have to check with their calculations. But all right, let's go and see if we can find the room. Let's see. You can see he has a bunch of gears. These are all gears, and they're labeled. The part studios are labeled. But let's see if we can find. Okay, so here he's got a wall. Okay, so here he's got a wall and it's got some holes in it. So here, now notice his sketches aren't fully defined, which is always not a great idea. But here, it does have the gears. Now, I personally like my gears to be lined up in a line. I'm not quite sure how we got the right distance between them, but I'm going to go through that more. Okay, I digress. All right, let me show the other example that I have. Let's see if we can find the assembly. Okay, so this is the one I showed you in class. There's a lot of things behind walls, so I'm going to see if I can hide a couple of walls. Okay. See if I can find this wall so you can see the gears going on inside. Where'd it go? There it is. All right. Let's see, and let's see how big this person made the, so this is like a 5-foot water wheel, which seems like a good size. Let's see if I can hide the water wheel as well, because it's kind of big and kind of makes it hard to see things. Okay, oh, and he has several parts to his water wheel. Okay, so here you can see it has a lot of compound gears. So I'm also going to try to hide this. And all right, that's probably good enough to show you what's going on here. There we go. So you can see as this shaft rotates, everything on the shaft is going to rotate together. So it's got this gear is driving, there's this whole, this is like one train here, these guys, okay, all the way over to there. This person used hex shafts. You don't have to use hex shafts. You can just use regular shafts, but that's fine if you want to use hex shaft. So you can see this gear is one of the driving gears for that gear train. And then this is a separate, this gear right here is driving this gear right here, okay? And let's see if there's anything else we can hide to get. Okay, so there's a lot going on, and then it has a third driving gear on there because they did 3 machines, which is driving this gear train down here. You only have to do 2 machines, okay? So I think the best example, what you're going to start with is just the first gear train, which I would mount on the wall. So it would be like this one, where this gear, you can see, is mounted on that shaft. They have like bearings and other things that you don't have to put on it. You need to have a shaft, and it could be a round shaft. They used a hex shaft attached to the water wheel, and then you need to have your gear. So this is like the first gear. It's a driving gear, and it's driving this gear right here. Okay, my guess is this is a 4-to-1 ratio. My guess is that this is, hold on. That's an 8-inch gear, 8-inch diameter. And this is our, hold on. This is a 32-inch gear. So this is a 4-to-1 ratio. So if this is traveling at like 30 RPM, this one here would be going at 120 RPM, okay? Now, this gear and this gear are on the same shaft, so when this one goes 120 RPM, that big gear in the back, this one, will also be going 120 RPM. And notice how that one is driving this little tiny gear right here. Okay, so if this one's going 120, and this is a 32, and this is an 8, now this next gear is going to be going 4 times as fast. Okay, so this gear is going to be going faster. It's attached to this shaft, and this is going, that's all going to be at the same speed, okay? And you keep going, and so that's driving this, which is going faster. And he did back and forth, where he goes back and forth, but you can just have it keep stacking in one direction if that's easier for you, okay? And it looks like there's a mistake here because it looks like this last gear should be aligned up with this, and it's not, but that's okay. Or maybe there's a hidden gear, but there's supposed to be a gear right here that meets up with that. Okay, so that's what you're going to be working on today in classes. You're going to be making your first gear train. And I want to show you this wall. Let me see if I can find the walls, because I think this is probably a better way of doing it. Is all the gears down here. You can see at the bottom, garage door open, table saw, shop fan. Oh, here we go. That's just like floor mat, shop sign, shop walls. Here we go. This is what I want. Okay, so I'm going to show you like one of these shop walls and some of these holes. I want to show you the holes. Is it all on there? Oh, let's see, show dimensions. Okay, so here, oopsie, show dimensions. So here, see how he has all of them in a line? I think that's the best way to do it. And the key thing here is having the center to center distance. So see, he's got 20 inches here. Now, if you had a 32-inch gear, the radius of that 32-inch gear is going to be half of 32, which is 16, right? And then, so if that's like mounted right here, you have a 32-inch gear on here, the radius is 16. Okay, now if you have an 8-inch gear mounted here that it's driving, the 8-inch gear has a radius of 4 inches. So 4 inches from this gear and 16 inches from this gear, if you add it up together, that's 20 inches. So the distance to distance from one hole to the other needs to be that distance, which is adding up the two radiuses of those gear trains. So you look at your gear train and you do that. Okay, so now let's, I'm going to do an example. You know what? I think I'm going to make a second video because this is pretty long and I'm worried about how it's going to upload.